Yes, hello everyone. Let us begin with the lecture. Just let me check once my voice is audible and the screen is visible, then let us begin the lecture. Okay. It is. Okay. Yes, so I welcome you all on the platform of Global Online. As we know, friends, Global Online platform has launched a complete course for upcoming CTET examination 2023, and in this particular course, we are discussing the whole syllabus of the CTET examination. So in this particular series, we have start up with the mathematics paper 1 as well as paper 2. In today's lecture, we'll be discussing the left out questions of mensuration from the topic of cube, cuboid and cylinder. Okay, so even the students who find themselves weak at mathematics can score maximum marks in the examination is the highlighting feature of this particular course. Before moving into the video, friends, for central teacher eligibility test, if you want to get enrolled to the complete course for the paper 1 or for paper 2, you can contact us on this given WhatsApp number, which is 8669316919 or 8179138413. You can download the global online application which is available on the Play Store and get enrolled to the course. Also, the highlighting feature of this particular course is that you will be provided with the one-on-one mentorship, okay, so that you can score maximum marks in the examination. Global online application is available on the Play Store, from where you can install the application. Once installed it, open the application. After opening, you'll find such type of interface. In this interface, if you look downwards, there is an icon named as a store icon. You have to click on it. Clicking on it will move to the page called as My Courses, and in My Courses there is a search tab. In search tab, you have to type CTET. Once you'll type CTET, course along with the fees will be displayed downwards, or else instead of going through these steps, you can simply contact us on this given WhatsApp number and get enrolled to the course for making your preparation and foundation stronger for the central teacher eligibility test examination 2023. So the first question of today's lecture is about the area of the cardboard, which is given in centimeter square, needed to make a closed box of size 20 centimeter into 10 centimeter into 8 centimeter will be what? So here they are asking us what should be the area of cardboard basically, so that for example, I'll tell you over here, so that we can enclose certain boxes of the given size. The size of the boxes given is 20 centimeter into 10 centimeter into 8 centimeter. For example, this is one box, okay, and the length, breadth as well as the height of the box is mentioned. Okay, so length 20 centimeter, breadth 10 centimeter and the height is 8 centimeter. These are the dimension of the boxes. Okay, now we have to enclose these boxes in a cardboard, okay. So first what we have to do, that we have to make a box out of the cardboard. Okay, in that particular box made out of the cardboard, we have to enclose certain boxes, these small boxes of the given dimension. So what are they asking? Basically they are asking us how much will be the area of the cardboard required to enclose this particular box of given dimensions. Okay, to understand this particular question, we'll understand few formulas regarding the cuboid first. Okay, so whenever we talk about cuboid shape, first thing that you have to remember here is cuboid is nothing but it is a rectangular box. What is it? It is a rectangular box. It is a rectangular box. For example, I'll draw here. Okay, so I'm not able to draw it perfectly, but try to understand it, that it is a rectangular box. Okay, if we look at this particular box and if we try to evaluate the things, that how many vertices are there, how many faces are there, the same thing as we have done in the cube shape as well. Okay, so in a cuboidal shape, first thing that you have to remember, it is a rectangular box which has length, width and height of different dimensions. Okay, length is different, width is different, as well as the height is different. But in case of cube, what we have seen, cube was a square box where the length as well as the width as well as the height of the cube was equal. But here the length is not equal to width is not equal to height. All the three things are different here. Okay, so this was the first thing regarding the cuboid, that the cuboid is a rectangular shape with different length, different width and different height. Okay, second point that you have to remember regarding this particular dimension is the lateral surface area, LSA, that is the lateral surface area for any cuboidal shape is what? Twice of BH plus LH. How come? I'll explain you that first. Okay, now we know that in this particular drawn box over here, which is the length, one second, I'll change the color of pen over here. This is the length, right? Here the breadth is this one, this is the breadth, and height is this, right? This is the height, H. So after looking at this dimension, we can clearly say that the lateral surface area is this face, the same at the backward sides, this lateral side, that is the 2 on the other side. Other than the top and the bottom face, all the faces are the lateral faces, keep in mind. Except the top, except the top and the bottom faces, all other faces are considered to be the lateral faces of any given shape, either it may be cube or cuboid. Okay, and we know that in case of rectangle, what is the surface area? So on the basis of that, we have find here the lateral surface area, that is there are two faces on the same side, same opposite sides, right? So here I have taken twice of BH plus LH. If we are talking about the total surface area that I have written here as TSA, then it is twice of LB plus BH plus LH. Okay, so here again the remaining two surfaces, that is two faces, have been included. One is the top face as well as the bottom face, in which case in the total surface area case. Okay, so now based upon this particular formula, we are going to solve this question. So before that, it was necessary to make you understand that the cuboidal shape is a rectangular box where the length, width and height are not equal. The second thing was the lateral surface area. The lateral surface area's formula is twice of BH plus LH, and the total surface area is twice of LB plus BH plus LH. And one more formula we'll discuss later on, that is the volume and the formula of diagonal. Excluding this thing that you have to remember here is that there are total 8 vertices, that is 8 vertex, 12 edges, same as in the cube that we have discussed before in this particular lectures. Okay, so there are total 8 vertices, these are the vertex. Okay, edges means these are the edges, this line drawn over here are the edges. And 6 faces, we know there are total 4 faces on the lateral side, this one, this 2, 3, 4, one top and one down, that is equal to total 6 faces. Okay, so this was about the cuboidal shape. Please remember that cuboidal shape is a rectangular box where length, width and height are different. Lateral surface area's formula, total surface area's formula. Excluding that, you have to remember the thing that there are total 8 vertices and 12 edges and 6 faces. Okay, so these were some of the formula and an introduction regarding the cuboidal shape. So now what they have asked us, in the question that how much area of the cardboard is required so that we will enclosed a box of size 20 centimeter, 10 centimeter and 8 centimeter. For this we have to understand the total surface area's formula will be required over here. Yes, LB plus BH plus LH. Based upon this, we can say that this box will be enclosed in this particular cardboard. Okay, we are making actually a box out of the cardboard, and for that we need a total surface area to find out. Okay, so here now twice of what is the length given here is 20 centimeter, breadth is 10 centimeter, and the height is 8 centimeter. Second thing that you have to keep in mind is here is that all the given dimensions are in centimeter, right? So here 20 into what is the breadth, 10, right? So breadth is what again, 10 into 8 height, plus length is again 20 into height is 8. So 2 into 200 plus what is this, 10 into 8, 80 plus 160. This will give me total as 880 centimeter square is the total area of the cardboard which is needed to enclose a box of this particular dimension. I hope you have got the question, and the answer to the correct question is option number A, 880 centimeter square. Moving on to the next question. Now here what is given, the area of 3 adjacent faces of a cuboidal tank are given 3 meters square. Okay, please just note down this, what exactly this is. Okay, I'll write here. What is given in question, they have given us that the area of 3 adjacent, just a second, the area of 3 adjacent faces they have given us, one is 3 centimeter square, 12 meter square, and 16 meter square. This is the given dimensions of a cuboidal's adjacent faces, 3 adjacent faces. Okay, so now the thing is we have to find the capacity of the tank in liters. What they have given, they have actually just mentioned the area of 3 adjacent faces. We have to understand what is this 3 adjacent faces of the cuboidal tank. I'll draw here one figure to explain you. Consider a single vortex. So here I am considering this particular vortex. Okay, so whatever the faces are attached to one single vertex are the adjacent faces of a cuboidal. What does it means? Now if we look here, if we look at this particular vertex, this vertex is in contact with this one face, right? Similarly, it is attached to the face at the downwards, right? One face at down, one face at the lateral side, which is upper side, and this is the other face. This one, this is the second face, and this is the third face. So there are total 3 faces. These are the total 3 faces where which this one particular vertex is in contact with, right? So these faces which are in contact with one vertex, these are called as 3 adjacent faces which are connected to a single vertex of a cuboid. I hope now you have got this statement, what does actually 3 adjacent faces of a cuboidal tank really means. Got it? That whenever we are considering one single vertex, then to that particular vertex, in case of a cuboid, there are total exactly three faces which are attached to it, right? One on the lateral side, this one. The second one on the downward side, this one, second, and the third on this one particular side, this one. This is the second and this is the third side. So these are the 3 total faces which are attached to one single vertex, hence called as 3 adjacent faces of a cuboidal tank. Now in question they have mentioned us the area of these 3 particular adjacent faces. Let us now draw once again the cuboidal tank. I am not able to draw it perfectly. Just please try to understand whatever I am explaining to you over here. Okay. So now For example, this is the vertex that we are considering. So this is the first face on the outer side, this is the second face on the downward side, and this is the third face on the lateral side. These are the three faces, and the area they have mentioned here is 3 meters square, 12 meters square, and the third one is 16 meters square. And they have asked us to find out the capacity of tank. So whenever we are finding the volume, whenever we are finding, now we are exactly finding the capacity, it means we are finding the volume, right? So whenever we are finding, please note it down, it is very much important, whenever we are finding the volume of three adjacent faces of a cuboidal tank, the formula will be volume is equal to under root of x, y, z. Please note it down. The formula for the volume of three adjacent faces of a cuboidal tank is given by volume is equals to under root of x, y, and z. There is a different formula for volume of a cuboid. Okay, please note one more thing, that the volume of cuboidal shape is equals to, or any cuboidal box is equal to length into breadth into height. This is one formula. This is the volume of the cuboid. But whenever we are talking about the volume of three adjacent faces, then this is the formula, that is volume is equals to under root of x, y, and z. So here under root of what is x? X will consider as 3, y as 12, and z as 16. Just note here 3 into 12 into 16. Okay, so this will give me under root of 576, and 576 is square root of what? 24. Am I right? Yes, got it. So this here you have to simply understand that we have exactly find out two formulas over here. One is the volume of cuboidal shape or any cuboidal structure. It is length into breadth into height. But whenever we are finding the volume of an adjacent faces of a cuboidal tank, it means the faces which are attached to a single vertex, that is three faces, then their volume is equals to under root of x, y, and z. These are the two formulas. Now the question that they have asked us in the liters. Yes, already we have discussed in our previous classes. 1 meter cube is equals to 1000 liters. It is equals to 1000 liters. So here we have to find this given value in liters. So 24 meter cube will equivalent to 24, that is 24,000 liters. Am I right? So the correct answer to the given question is option number C, that is 24,000 liters is the capacity of the tanks in liter. Just remember two formulas, the volume of the cuboidal shape and the volume of the cuboidal shape with the three adjacent faces of any cuboidal given shape. Okay, so these are the two different formulas. Moving on to the next question. Look here, we are not just going through the questions. Basically we can simply, I can tell you simply the what is the formula or whatever the formula we are going to use for a given particular question, but we are at the same time understanding the shape of the cuboid as well as cube, and here we are also understanding what are the different formulas that we have to use. So this class is actually very much important for paper 1 as well as for the paper 2. Now given here the maximum number of 4 millimeter into 50 meter into 20 centimeter slabs that have been stored in a 16 meter long, 12 meter wide, and 4 meter depth trench is. Please cut it down, cut this. The question is, how much or the maximum number of slabs or how much slabs of a given dimension, what are the dimension given of the slabs? The given dimension of the slab are 4 millimeter into 50 centimeter. Actually this is not a 4 millimeter, this is only 4 meter. Please note it down, not 4 millimeter, this is, yes, it is 4 meter. I'll just correct once. and this is the question that has been previously asked in your examination, so just go through the question once. So the given dimension of the slab are 4 meter, 50 centimeter into 20 centimeter. This is the dimension of slab, and these slabs we are going to store, in a trench, or we can also consider it as a box. Okay, the given dimensions of the trench are 16 meter into 12 meter into 4 meter. These are the dimensions of the trench, these are the dimensions of the slabs. Okay, now we have to insert these slabs in the trench. We have to just keep those slabs in the trench. So what they are asking us, how many numbers of slabs we can actually insert or add in that given trench of dimensions. Okay, so here what we can do, simply divide the dimensions of the slabs with the dimensions of the trench. These are the dimensions of the trench, right? Yes, divide it with the dimensions of the slabs, that is equals to 4 meter into 50 centimeter into 20 centimeter. Now here the given units are different, right? Here the given units for trench are meter, as well as the slabs given here is a single is given in meter, the other two are given in centimeter. So we'll convert this centimeter into meter. So one thing that we know, that 1 meter is equals to how many centimeter? 100 centimeters. So 1 centimeter is equals to 10 raised to minus 2 meters. So I'll multiply here by minus 2 and here again by minus 2. So simply I'll do it here by 10 raised to minus 4. Can I do this? Yes. 10 raised to minus 2 for this, 10 raised to minus 2 for this particular given dimension. So the total will be 10 raised to minus 4. Now you can simply cut it down. Okay. Yes, again this will give me 1920. Yes, 1920. Got it? So here the answer for the given question is option number D. Now this is the type of question that can be directly asked in the examination, and such types have been before asked also in the previous year question papers, if you look at them. So such type of question we have seen actually in the cube shape also, as well as in the cuboid shape also. Okay, so make that thing, remember that in whichever the box we are going to add the other boxes or any other thing, we have to divide it by that particular thing. Okay, the larger box will come in the numerator, and the things that we are going to place in it will come in the denominator. Simply this was the thing that you have to remember. Now moving on to the next question, again a question from the previous year question paper. Rajesh went to pack 4000 cubes in offside 1 centimeter in various boxes. Now this question you might be finding very difficult because the question is quite lengthy, but the question is very much simple. Try to understand the question first. Now Rajesh want to pack 4000 cubes offside 1 centimeter. Now given dimension is given dimensions for the cube are, the side given is 1 centimeter, so the other sides will be also 1 centimeter as well as 1 centimeter. Yes, length, breadth and height will be 1 centimeter. Now this particular cubes we have to pack in various boxes. There are different boxes or different dimensions mentioned to us over here. So let us check those dimensions. The given dimensions are, first box, for example, let us consider the box number A as 20 centimeter into 10 centimeter into 6 centimeter is the first box. 20 centimeter into 10 centimeter into 6 centimeter is the first box, right? This is the dimension of the first box. The dimension of box number B, is 15 centimeter into 9 centimeter into 10 centimeter. This is the box B. 15 into 9 into 10. Okay, let us find similarly for box number C. For given box number C, the dimensions are 11 centimeter into 11 centimeter into 10 centimeter, box C. And for the box D, the dimensions given are 6 centimeter into 4 centimeter into 10 centimeter. The first thing that you have to clear here is all the given dimensions are in the same unit, that is centimeter. So no jhanjat or no problem for conversion of the units. Okay. The second thing that you have to remember, right now I have told you that whatever the given box in which we are going to pack the other boxes will come in numerator, and the one which we are going to pack inside the box will come in denominator. Now in denominator it is going to come 1 centimeter into 1 centimeter into 1 centimeter. So whatever we are multiplying it by, or we are dividing it by 1 into 1 into 1, yes, we are going to divide it by 1 into 1 into 1. It is basically negligible. Same amount of number is going to come even if you are dividing it by 1. Simply here also we are going to divide it by 1 into 1 into 1. Here also 1 into 1 into 1, as well as in the case of D also we are going to divide it by 1. So whatever the multiplication is going to come here will be your directly answer. So 20 into 10 into 6, this will give me 1200. Yes. Next 15 nines are, this will give me 1350. Right. 11 into 11, 121 and 0, that will give me 1210. Similarly 6 into 4 into 10 will give me 240. One thing that you have to simply remember is the box in which we are going to pack other boxes will come in numerator, and the boxes, the small boxes that which we are going to pack in the big box will come in denominator. Simple. Those dimension will come in denominator. I am saying it in simple words. So the correct answer for the given question will be option number D, 1200, 1350, 1210 and 240. Okay. Moving on to the next question now, again of same type. What is given here? Meenu has a cube of side 1 centimeter. She can arrange exactly 30 such cubes in her box. If Mahima has a rectangular shaped dais with a length 2 centimeter, breadth 1 centimeter and height 1 centimeter, how much such dice she can arrange in Meenu's box if it is empty? Okay. So Meenu's cube that they have given, the size of the Meenu's cube is 1 centimeter. For example, this is that cube, and the size of the cube that they have mentioned is, or one side that they have mentioned is 1 centimeter. The rest of the sides will be also 1 centimeter. Am I right? Yes. Now she can arrange 30 such cubes in her box. Okay. Now these are the small cubes that we are going to arrange in a box. For example, this is that box. In that box, she is going to arrange these small cubes. Okay. When she is starting arranging the cubes, total such cubes that she can arrange in this box, total cubes that she can arrange in this box are 30. She has arranged total 30 such cubes in a big box. Now, same box which Mahima has now is in rectangular shape. It means a cuboidal box. This is the box of Mahima which is in the rectangular shape. This is in the rectangular shape. Okay. Rectangular shape dais with length is given 2 centimeter, breadth is given 1 centimeter and the height is given 1 centimeter. So how much such dais she can arrange if a Meenu's box is empty? Please keep in mind. Now Mahima has a rectangular shaped dais. Now this is one dais. This is not a box. Please I have just make a mistake over here, that this was the cube of Meenu. This was the cube of Meenu which she arranged in this box. Okay. Now this was a cube for Meenu. Now but this is a same box but in a rectangular shape, that is a cuboidal shape. This is a cuboidal shape of Mahima. Now she want to arrange these cuboids in this shape. Okay, I'll just explain you by making things quite clear over here. There was a little confusion. For example, this is a cube of 1 centimeter. 1 centimeter, side 1 centimeter. Okay, so this is a Minu's cube. Okay, and we have a cube with a rectangular shape now, and its dimensions are mentioned with a length of 2 centimeter, breadth of 1 centimeter, and height of 1 centimeter again. And we have a big box, who the box belongs again to this box. Big box belongs to Minu. Okay, if Minu starts arranging such many cubes in this box, then she can arrange 30. She can arrange such 30 boxes in this large box. And if Mahima has a rectangular dais, now this is the dais of Mahima with the given dimensions. So if we start arranging the dais of Mahima in the box, then how many dais of Mahima can be arranged in the box of this, in this particular box? This is the question. So simply again, Minu's box dimension, that is this particular box dimension, divided by this particular box. What is the dimensions of Minu given here? 1 centimeter into 1 centimeter into 1 centimeter, multiplied by 30. Why I'm multiplying it by 30? Because this is the size of the cube, and such cubes when arranged in this box, then 30 cubes can be occupied in the box. So what will be the dimension of this box? The dimension of this box will be 1 into 1 into 1, which is the dimension of this cube, into the 30 such cubes that have been arranged in the box. This will give us the dimension of this bigger box. Okay, so divided by the dimensions of the Mahima's box, that is 2 centimeter into 1 into 1. This will give me 15. Got it? So when we start arranging the Mahima's rectangular dices in the Minu's bigger box, then the total number of Mahima's dices will be 15 that can be occupied in this. Got it? Yes. One thing that you can highlight over here is, whenever we are changing the dimension of one given box, okay, now here the dimension of it was of cube, given 1 centimeter as a side. Here the dimensions have got completely changed, the shape has got completely changed. Whenever we are actually organizing a bigger shape in a box, that time such boxes will be arranged in a smaller number, right? So this is the thing that you have to remember here. So this were some of the few questions that we were discussing about the 3D structures. Okay, these are important for paper 1 as well as for paper 2. In tomorrow's lecture, we'll be talking about the cone and cylinder. Once done, then we'll be completing the chapter of the mensuration. Okay, so after that we'll start a new topic, but it will take at least 1 day, at least one lecture where we can complete the mensuration. Okay, so this was the end of today's lecture. I hope you are liking the video. If you are liking the video, please hit the like button and let me know in the comment section if you have any kind of doubt regarding the lecture. Okay, so yes, if you have any kind of doubt, you can let me know in the comment section. Yes, Avnish Kumar. Fine. Thank you for watching the video. Have a great day, everyone. Bye.